watching this video. So on this video we are going to do question 3 of November 2020 question paper Physical Sciences paper 1. So we'll start with question 3 as I said. So I'm going to read the question. So I've drawn the graph here which is from question 3, but I'll also show the question paper as I'm reading so that you can pause and read the question paper by yourself and see from the more accurate drawing of this graph, because this is handwritten, so it might not be as nice as you might want it to be. So let's go. A small ball is dropped from a height of 2 meters and bounces off a few times after landing on a cement floor. Ignore the air friction. So a cement ball is dropped from this height of 2 meters and it bounces off the floor several times. So it bounces here and it bounces there. So it bounces on a cement floor. So this is a position time graph. It shows us the position of the ball versus time. So it's dropped from 2 meters, bounces off. So this is the time in which the ball is in contact with the floor, and it bounces again, reaches the maximum height and goes down again, contact with the floor. That is that time that is in which the ball is in contact with the floor, bounces again, reaches the maximum height and get there to the time t. So as I said, so if you are dropping the ball, so it's it going down here. This is the time it takes to get to the floor. And then here again, this is the time in which the difference between two, in which the ball is in contact with the floor. It goes up, reaches the maximum height, goes down, hits the ground or the floor again. This is the time in which it is in contact with the floor. Goes up, reaches the maximum height, and it goes down again. So this ball of ours bounces off the floor several times. So let's go to the first question. Question 3.1. Define the term free fall. So what is free fall? So free fall, it refers to objects that are falling under the influence of gravity only. For example, if you note what they said here on this question, they said ignore the air friction. So if I hold this marker here and then I leave it, it falls down. What causes it to fall down? It's gravity. I didn't apply a force on it. Gravity is the one who caused that falling of this object. It's the gravity who caused the motion of this object. So when you're talking about free falling objects, so in my room like this one, or my studio, my office, whatever that you would like to call it, I have a friction, so there is a friction here. So I wouldn't say this marker falling here is free fall, because of course there are a friction as it's going down, a friction is pushing it upwards. But now when they say ignore the effects of friction or there's no air friction, that means now, that would mean that if I were to say in my room there's no air friction, then this marker falling down is falling under the influence of gravity only. So this motion is influenced by the gravity or the weight of this object. So to define free fall, you say free fall is a motion of an object that is influenced by gravity only. So that motion of this object is influenced by gravity. The only force acting on that object is gravity. So that's what you mean by the term free fall. So let's go to question 3.2. Use the graph to determine the time that the ball is in contact with the floor before the first bounce. So we said this ball is released here and it goes down, boom. And I said this time here is the time in which the ball is in contact with the floor, this one. So what they're asking you, they are saying use the graph, which is this graph, to determine the time that the ball is in contact with the floor before the first bounce. So this is the first bounce, that is the second bounce. So the time that you want is the time in which the ball is in contact with the floor the first time, which is this time here. So let's go and calculate it. So to find it, it will be the difference between this time and that time, because our ball landed on the floor at 0.64 and bounced off the floor at 0.67. So the time it is in contact with the floor, it should be the difference between the two times, because this is the arrival time, this is the departure time. So the time stayed will be the one that is lost in between. So let's go and do it. So the time of departure is 0.7, which is time of bouncing. The time of arrival is 0.64. So to answer our question, the time of the first contact. So T first contact is equal to 0.67 minus 0.64, which is equal to 0.03 seconds. So this is the time in which the ball is in contact with the floor for the first time. So let's go to the second question. 3.2.2. Use the graph and determine the time it takes to bounce, or it takes the ball to bounce. Determine the time it takes the ball to reach its maximum height after the first bounce. So they want us to determine the time which the ball takes to reach the maximum height after the first bounce, because this is the first bounce, that is the second bounce there. So they want us to find the time it takes to reach the maximum height. How long did it take to reach the maximum height? So we know from projectile motion that the time it takes for an object to rise to reach the maximum height and return to the same position, it takes the same amount of time. So the time it takes to rise to this maximum height and return to that same position, that time will be equal. So now, which means that the time that we are looking for is the midpoint of these two, which means it left at this time and arrived at that time. So how long did it take to move the entire motion? And then we have that, because we know that the time takes because if it takes 2 seconds to move from here to that point, we would know that it took a second to get to the maximum point, and took another second to the return position, to return to original position. So now what you must do is to find this time in between here and then half it, then you will know how long did it take. So to answer this question 3.2.2, let's go. So it's 3.2.2. So T, maximum height, is equal to the time it returned. So it returned at 1.90 minus 0.67. So, and then divide by 2, because the time that you will get here from 1.9 minus 0.7 is the time of rising and returning to the original position. Then halving it is only giving you the time it took to go up, which is the time that we want. So what, use a calculator. 1.9 minus 0.67 divide by 2. So it's 0.62 seconds. So this is the time to reach the maximum height. So the ball took 0.62 seconds to rise to reach the maximum height. So we can say that it took 0.62 seconds to go up and another 0.62 seconds to go down. So that's what this means. So if you want the time here, you'll just add 0.62 to 0.67. It will give you the time here, which is about 1.29. So this is how you answer this second question. Let's go to another question. 3.2.3. Use the graph and determine the speed at which the ball leaves the floor after the first bounce. So they want us to use this graph and calculate the speed at which the ball leaves the floor after first bounce. So the first bounce is here. So which means now they want this speed here. We know the speed there. And we're given the height of that position, sorry. So this is 1.85. And that is this, what is it? Let me check. That is 1.2. 1.2. So they want us to find this speed here, the velocity here, at which this thing bounces off the ground. So to do this, we know our final velocity. We know the displacement, and we know the initial, or what the initial velocity. We have the time as well. So what you can do is say, okay, given that information, this is what we can do. So 3.2.3. 3.2.3. We can say, okay, Vf squared is equal to Vi squared plus 2a delta y. We know Vf is 0. We know Vi. Oh, we don't know Vi. We know these two. So, final velocity is 0 because at the maximum height, it's 0 where the maximum height, the velocity is 0. So we can say, okay, 0 squared is equal to Vi squared plus 2a. For my sake, I use up as negative, up as positive, and down as negative. So we have negative 9.8 times delta y, which is 1.85, which is I squared is equal to these two times negative 9.8, 1.85. So this was positive, it should be negative this side. So you have negative 36.26. So you can divide by negative sign both sides. You don't have to do this. Take the square root of this, take the square root of that. So Vi is equal to square root of 36.26. Square root of 36.26. And that is 6.02 meters per second upwards. So this is how you answer 3.2.3. Then we proceed to the next question. We do question 3.2.4. Read as follows. Use the graph and determine the time t indicated on the graph. So they want us to use the graph and find this time here, the time t indicated on this graph. So they want us to find that time. To do this, the first thing that I would say we must do is to find this time here, the time it takes to reach the maximum height. So once we have that time, we will know how long did it take to reach t, because reaching the maximum height is half of the time of the entire motion to go up and return to the original position. So what we need to do is find the initial velocity here, in my case, we have the final velocity there. If you find the initial velocity, then you can be able to find time there it takes to reach that maximum height. So let's find the initial velocity. So we use the calculation similar to the previous one. So we say, okay, so we say, okay, Vf squared is equal to Vi squared plus 2a delta y. So I took my motion up as positive and everything that goes down as negative. So my final velocity at the maximum point there, which is where I want to find the time for. Because I want to find the time, this time, for this position here, which is this one here. So this is the maximum position of the second bounce. So I know Vf is 0 there, and I want the Vi of this area. So we know the height, which is the position, is 2 meters. It's 1.2 meters. So we can use that equation that I've written that side. So let's go. So we say, okay, Vf squared, 0 squared is equal to Vi squared, which is what we don't know, plus 2a, which is our gravitational acceleration, 99.8 times 1.2. 1.2. 1.2. So Vi squared is equal to, take this and transpose it to the other side. Okay, let me just do it proper so I don't confuse you. So 0 is equal to Vi squared minus, so you punch this in your calculator. So it's 2 times 9.8 times 1.2. So this is 23.52. So you transpose this to the other side. So 23.52 is equal to Vi squared. Then take the square root, take the square root. So Vi is equal to the square root of your answer, which is 4.85 meters per second. So now you have the initial velocity. You have the initial velocity to be this, which means now you have this velocity here. You have this velocity here, this one, to be 4.85. So this V here is 4.85 meters per second. So now you can find the time it took to slow down from 4.85 to 0. Once you have this time, you double the time, which means now you will have that time as well, because the time it takes to reach the maximum height is the same time it takes to reach the initial starting position. So let's go. So now we want to find how long did it take to get to 0, which is now, that will be the time. How long did the velocity takes to move from 4.85 to 0 meters per second? So that is our next question. So now we're going to do that. So okay, Vf is equal to Vi plus A delta t. So we have the final velocity to be 0. We have the initial velocity. We want the time. So this is the time it takes to reach the maximum height. Once we find this time, we double it because we want it for the entire motion. So I will clean this. So we said, okay, Vi is equal to 4.85 meters per second. So Vf is equal to Vi plus A delta t. So Vf is 0 VI is 4,85 plus A, which is negative 9,8 delta T. So transpose this, so you have negative 9,8 delta T is equal to 4,85 divided by 9,8 divided by 9,8. So delta T is equal to 4,85 divided by 9,8. That is 0,49 seconds. So this is 0,49 seconds. So this 0,49 seconds is the time. This 0,49 seconds, let me go back to the question, is the time it took to move from this position to that position. Which means now, to move from here to here is 0,49 seconds. So to move from here to here is another 0,49 seconds. So now, the entire time of the motion is 0,949 seconds times 2. So the time of the entire motion, T total, is equal to 0,49 times 2, which is 0,98 seconds, which is equal to 0,98 seconds. So this is the time of the entire motion. So now 0,98. But now what they want there is that time T. What is the value of T? So the value of T is going to be 0,998 seconds, because you know that from here to this point you take 0,98 seconds. So you must add 0,98 seconds here, then you will get the value of T. So the value of T, that T there, that T, so T is equal to 0,98 seconds, which is that of the motion, plus this 1,97 here. So now you have that value of that, because you know it's 0,9 seconds, 0,49 to move up and down. So now to add it here, you find the value of T. That's 1,97, which is equal to 0,98 plus 1,97. That is 2,95. That's 2,95 seconds. So that is the value of time. So here we have 2,95. That's how to answer this question. I hope we are clear.